Assalamu alaikum students, welcome to the second lecture of chapter Chemical Thermodynamics. In our previous lecture we have discussed what is meant by chemical thermodynamics, what are the scopes and limitation of chemical thermodynamics, what is the basic concept of thermodynamics, that is what are the types of system which we can study, what are the types of properties which we may discuss, and how these properties were classified as extensive properties and intensive properties. And we have discussed what is mean by state of the system, what is mean by state function and path function. We have completed these important terms in our previous lecture. Okay. Today let's begin the lecture with the term thermodynamic equilibrium. Look, we all know the meaning of word equilibrium. Whenever you hear the word equilibrium, the one thing should come in your mind that it is talking something about which is in balance or which in equality with the opposing force. It means two different kinds of forces are there or influences are there, and these two influences or forces are in balance with each other, are in equality with each other. Okay. So what is thermodynamic equilibrium? Thermodynamic equilibrium is a state of the system where system is in equilibrium with the surrounding. It means that it is such a state of the system where you will observe no change in the state function with time. Okay? So a system can be, or a system is said to be in thermodynamic equilibrium when the state functions of the system do not change with time. In simple words, if you observe no change in the system, you will say the system is in thermodynamic equilibrium. Whenever any system is in thermodynamic equilibrium, you should always understand that the system is in automatically three different types of equilibrium. If I am saying a system is in thermodynamic equilibrium, it means that system is in thermal equilibrium with the surrounding. That is, the temperature of the system and surrounding are in thermally equilibrium. It means are equal. Then it is in mechanical equilibrium with the surrounding, that is internal and external pressure of the system must be same. Okay. And it is in chemical equilibrium. It means the chemical composition of the system is not changing with time. Okay. So a thermodynamic equilibrium means a system is in thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Okay. And in simple words, it is what? A system is said to be in a thermodynamic equilibrium when the state functions of the system do not changes with time. Okay. Now, if the system is in thermodynamic equilibrium, it means that the system is not undergoing any change. The state of the system is constant with time, it is not changing. But when the system moves from one thermodynamic equilibrium state to some new thermodynamic equilibrium state, it means the change has occurred, the transition has occurred. And this transition from one equilibrium state to another equilibrium state is known as process. Okay? And what we do in thermodynamics, we study the processes, we study the changes, we study the reactions. Okay? When nothing is changing, it is not interested to study that thing. If something is not going to change with time, you know it, you are not going to study that. Okay? So when the system moves from one equilibrium, thermodynamic equilibrium state to some other equilibrium state, a transition will occur in the state of the system. Okay, and that transition from one equilibrium state to another equilibrium state is known as is known as process. Okay, so I hope you have understood the meaning of thermodynamic equilibrium. And what is process? Process is change in the or transition in the state of the system from one equilibrium to some another equilibrium. Okay. Now there are different types of processes which we can study in thermodynamics. Basically we will discuss in detail only 5 types of processes which we are going to learn in chemical thermodynamics. The first process we'll discuss today is isothermal process. Which process? Isothermal process. This is the first type of process which we will discuss today. Now we know the meaning of iso. Iso means same, okay, and thermal here will represent temperature. It means that it is a process in which process is happening means what? Change is happening, okay. So it is a change or transformation in the state of the system which is carried out in such a way that the temperature of the system remains same or remains constant. It does not change with time, okay. So a process which is carried out in such a way that the temperature of the system remains constant throughout the change or throughout the transformation is known as isothermal process, okay. You can use the different words, but the meaning of the word should not change, okay. So a transformation or process in which the temperature of the system remains constant throughout the transformation is known as isothermal process. It means I am saying what? That T is constant. And T is constant, it means the change in temperature, that is when the system moves from T1 to T2, we know that to find the change we subtract the initial value from the final value. So we are saying what? The T2 and T1 are same, therefore the change in temperature is 0. And remember, when the temperature of the system is not changing, it is not changing with time, what is happening? The internal energy of the system will also not change, okay, because the change in temperature will indicate the change in internal energy of the system, okay. So when T is constant, the internal energy of the system also remains constant, and the change in internal energy of the system will also be 0, because there is no difference in U2 and U1, okay. There is no difference in T2 and T1. T2 and T1 are same, okay. So when they are same, their subtraction will give us 0, okay. So this is how we explain the isothermal process. These are the two important points which you should mention while mentioning the isothermal process, okay. Now let's see the second type of process now. Now the second type of process which we will discuss is isobaric process, okay. Baric means what? Pressure. So you must have understood it is which kind of process? The process in which the pressure of the system remains constant throughout the change is known as isobaric process. So here you should mention what? That process pressure is what? Constant. And therefore change in pressure is 0. Okay. Such a process which is conducted in such a manner that the pressure of the system remains constant throughout the change is known as isobaric process. Look, generally most of the reactions and processes are carried out in the laboratory are what? At constant pressure, okay. We have done different practicals in the lab also. In none of the practical we have changed the pressure of the system or the reaction. We have carried out the reaction in test tubes and in beakers, and the chemicals were subjected to the external pressure which is constant, okay. So in general most of the reactions are carried out what? At constant pressure, okay. So what is isobaric process? A process in which the pressure of the systems remains constant throughout the change is known as isobaric process. And you will mention that P is constant, therefore delta P, that is change in pressure, is 0. Okay. Now the third type of process is isochoric process. Now it is isochoric process. Okay, choric stands for volume. Okay, so any process conducted in such a manner that the volume of the system remains constant throughout the transformation is known as isochoric process. So the process in which the volume of the system remains constant, it does not change, is known as isochoric process. It means we are saying that V is constant, therefore change in volume is 0. Okay. Now such type of processes where we don't want the volume of the system to change, we do what? We take closed system, so that there should not be any exchange of matter with the surrounding. Okay. So which kind of system is suitable for isochoric process? Always we will take what? Closed system. Okay, because it will not allow the exchange of matter with the surrounding, hence prevent the change in volume of the system. So the definition is very simple, all are same. You will just write a process in which the volume of the system remains constant throughout the transformation is known as isochoric process, and you should also mention that V is constant, therefore delta V is equal to 0. Okay. Now the fourth type is adiabatic process. Now in adiabatic process what happens? The process is carried out in such a way that the system cannot exchange heat with the surrounding. Okay. So there is no exchange of heat between the system and the surrounding. Then we will say the process is what? An adiabatic process. Okay. Now which kind of system would be suitable for this type of process? We don't want any exchange of heat with the surrounding. So it should be what? An isolated system only, because in isolated system what happens? The wall of the systems are thermally isolated with the surrounding. Okay. So this wall will not allow the exchange of heat with the surrounding. Okay. So a process in which a system cannot exchange heat with its surrounding is known as adiabatic process, and it is carried out in what? Isolated system, and the wall of the system is termed as what? Adiabatic wall. So these walls of the system is also termed as adiabatic wall or thermally insulated wall. The system should be thermally insulated from the surrounding. Now whenever any process happens in this condition, what happens here? The system is not able to exchange heat with the surrounding. So suppose a reaction is taking place adiabatically, a reaction is taking place. Okay. Now when the reaction takes place, the heat may be given out or heat may get absorbed during the reaction. We know that the reactions can be exothermic or endothermic. Exothermic means what? Heat releasing, and endothermic means what? Heat absorbing. So when a reaction takes place in this manner, that is in adiabatic process or adiabatically, the heat may be given out or heat may get absorbed during the reaction. Now the heat cannot be taken from the surrounding and cannot be given out into the surrounding because the process is adiabatic. It does not allow the exchange of heat due to the thermally insulated wall of the system. So when this happens, what happens? When there is no exchange of heat, that is change in exchange of heat is 0, what happens to the temperature of the system? Will the temperature of the system remain constant? No. The temperature will not remain constant now. So if the process was exothermic, heat releasing, it will add heat into the system. Temperature of the system will rise. And if it is an endothermic reaction, it will absorb heat which is already present in the system, and the temperature of the system will go down. Okay, so the temperature does not remain constant in case of adiabatic process. Therefore, delta T is not equal to 0. Okay, why the temperature is changing? Due to the exo or endothermic nature of the reaction, the heat may get consumed or may be given out during the reaction, which will cause the change in temperature of the system, and the temperature will not remain constant, and delta T will not be equal to 0. It will have some value. Since the temperature of the system is changing, the internal energy will obviously change. Okay, because temperature is one of the way of measuring how the internal energy is changing in the system. So U is also not constant. U is what? Your internal energy of the system, and delta U is also not equal to 0. Okay, so always relate temperature and internal energy with each other. What is internal energy? We'll discuss it in detail afterwards. Okay, so how we have described the adiabatic process. What is mean by adiabatic process? A process conducted in such a manner that there is no exchange of heat between the system and the surrounding. Such processes can be carried out only in isolated system which have the adiabatic wall, that is thermally insulated wall. Okay, when this happens, the transfer of heat Q is equal to 0, because heat is not being exchanged with the surrounding. But the temperature and the internal energy of the system will change. It will not remain constant because of the nature of the process which is taking place. The process can be exothermic or endothermic, depending on which the temperature may increase or may decrease during the process. Okay, so this is what adiabatic process. And the last one will be your reversible. The last process which we will discuss is reversible process. Now from the name you can guess reversible means which can be reversed, and why it can be reversed that we'll see. Okay, now what is reversible process? A process in which the driving force is only infinitesimally greater than the opposing force, and that can be reversed by just slight increase in the opposing force. It means that whenever any process or any reaction takes place, two process occurs or two process functions at the same time. Okay, one force is termed as driving force that takes the process in the forward direction, and one process is force is known as opposing force that try to bring back the process to the previous condition into the backward direction. Okay, so whenever any reaction or any process take place, two forces simultaneously act there. One is termed as driving force, which is pulling the process towards the forwards direction, and one is termed as opposing force, which is pushing the process to the backward position. Okay, now when these two forces are very similar and there is only a small infinitesimal difference between them, it means that the process is taking place, it means it is moving in the forward direction. Okay, it means that the driving force is only infinitesimally greater than the opposing force, but you can reverse this by making certain changes in the condition which will cause what? Opposing force to become stronger than the driving force. Okay, so a process conducted in such a manner that the driving force is only infinitesimally greater than the opposing force, and that can be reversed by the slight increase in the opposing force, is known as reversible process. Okay, so reversible processes are of great importance in thermodynamics, because you will study that this kind of reversible processes help us to obtain the maximum work from the system. Okay, now for example, there are some very important features of these reversible processes. All the reversible processes are very slow. Okay, and it is assumed that they occur so slowly that the changes occur in such a way that at every stage several other thermodynamic equilibrium is achieved. For example, suppose a system is moving from state 1 to state 2. Now, if this is a reversible process, this change will not occur suddenly, but it will take place very slowly. Okay. Now, this slow process will occur in such a manner that you can divide these changes into several infinitesimal small changes, and the changes will happen in such a way that when the system moves from one change to another small step, the system will take a very small step at each time. Okay. Now this change will occur so slowly, and the system will do what? Will move from one equilibrium state to another equilibrium state. And this change in equilibrium will be very small, and the system attains the equilibrium and again move for the change in a small step. Again it will acquire equilibrium. Again it will move from another change, and again it will acquire equilibrium. It means you can divide the whole change from one state into another state into several different small parts, and at each small part a new equilibrium is achieved. Okay. So this change from one state to another is not a sudden change, but it is a very slow process, and it takes place in infinitesimal number of small steps, and at each small step an equilibrium is achieved. Okay, for each small step an equilibrium is achieved, and then the system moves from that small change to another small change. Okay, so these are some important features that the reaction reversible processes are very slow. It takes place in infinitesimal number of small steps, and the equilibrium is maintained for reaching all that small steps. And you can say that for each small step, the system, you can say that, is always in pressure and temperature equilibrium with the surrounding. Okay, so these changes will occur in such a manner that you will not be able to observe when the changes have occurred. Understood? For example, let's take a gas enclosed in a container. Okay. Now, if a gas is enclosed in a container, some gas is enclosed in a container, and the system, this gas is in this thing, equilibrium with the surrounding. Okay. Now, let's say that we have covered this container with a weightless, frictionless piston. Okay. The pressure of the gas which is enclosed in a container will have some pressure. Okay. And there will be external pressure acting upon this piston. So, as long as the internal and external pressures are same, the piston will remain on its position and it will not move, and we will say that the system is in equilibrium. Now let's say because of some reason the external pressure has decreased. Because of some reason the external pressure is now less. Now the equilibrium is disturbed now. Now the internal and external pressure are no longer same. Now what will happen? Now to make the internal, to attain the equilibrium again, look, every system or the reaction will always continue to change until it acquires the equilibrium state. Okay. So as the equilibrium has disturbed due to the decrease in external pressure, now the system will start changing and it will try to acquire the equilibrium again. In equilibrium, the system is at stable state. Okay. So to make its pressure equal to the external pressure, the gas inside the container will start expanding. Why it is expanding? Because we know that pressure and volume are inversely proportional. to decrease the pressure, the volume is increasing. Okay, so because of which what will happen, the gas will expand and now the piston will move up until it acquires what? The value of pressure which is equal to external pressure. Now this expansion of gas will take place very, very slowly. Okay. Now the expansion will take place very slowly. In the same way, if the external pressure has increased due to some reason, what will happen then now? If the external pressure is increased and internal is less, the internal pressure will also try to become equal to the external by undergoing compression. Okay, by undergoing compression, the internal pressure will also increase by decreasing the volume. Compression is decreasing volume. Okay, now which kind of process is this? This expansion and compression of gas due to changing the external pressure is which kind of process? It is a kind of reversible process. Okay, so due to the change in the pressure by infinitesimal amount, we can reverse the change. Okay, so such type of processes are called as reversible processes, and this is one of the example of reversible process. Okay, so here we have finished the types of processes which we are going to study in chemical thermodynamics.